So Stuart, what is the project we're looking at today and what does it involve?
Right, today, Tony, we're looking at a construction project of a block of flats, and we're looking at the foul drainage water system. Obviously there's two systems in any construction project, one for clean water, one for foul water. But today we're in particular going to look at the foul water. So any of the WCs, baths, any waste pipe, any wastewater from the properties has to be drained away to the main sewer in the road. So what we're going to be looking at today is getting that foul water from the properties to the main sewer in the road, complying with building regulations, and looking at the ease of installation and key features and benefits of the actual products we sell to achieve that.
And this is the starting point.
Right, in this typical application, we start the drainage system off with a rest bend. This is a long radius sweeping 90-degree bend, conforms with building regulations. It has a hill on the middle of it, and what this is there for is to stop any discharge from the pipe above dislodging the fitting. So what happens is, fits on there, the hill will go on a brick or some aggregate to dislodge like that, and the soil vent pipe will attach to there, taking the foul water through the property.
And I take it this is a typical plastic drain pipe, Stuart?
It's not exactly the case, Tony. This pipe is made with recycled technology. It performs in exactly the same way as any standard drainage pipe, yet it's made with over 50% recycled materials. The pipe is a triple layer pipe. The outer layer is virgin plastic, inner layer is virgin plastic. The core is made with high quality recycled materials. Where the technology comes into it is it's all extruded as one piece, which then gives it the same impact resistant and thermal resistant properties as standard EN 1401 pipe. It is a product unique to Wavin, and it helps the developer increase their sustainable credentials in a build.
So the guys are about to put the full length of pipe into this section, Stuart, but I've noticed there's some couplings on here. What are they for?
Well, it's what we call a rocker pipe, basically to allow for any settlement, ground movement. As the pipe moves through the foundations, you want to allow a little bit of movement, and the coupling each side has a slight amount of tolerance on. So if there's any ground movement or settlement like that, it will allow for that and not damage the pipe. One of the benefits of using an Osma fitting is the captive ring seal system. This makes it impossible to dislodge the sealing ring while making a joint. What you would generally do, the lubricant around the edge of the pipe, we do this for ease of insulation. Put the pipe into the fitting and then push down, and there you go, you have a completed joint there that's fully inserted.
So the ground workers are ready, let's carry on with the installation. So Stuart, what have the workers actually just done?
Well, what Pat and Sean have just done here is laid the 110mm pipe on a 100mm bed of 10mm shingle. Three reasons for that, Tony. One, it's a great regulator to get you falling. Two, there's no inherent strength in the plastic pipe. So the pipe derives its strength from the compaction of the granular materials around it. And thirdly, it protects it from any kind of damage.
And we're all ready to go now. I take it there's nothing else, Stuart?
No, what they've done here, they've only half-barreled the pipe, basically filling the shingle up to the top of the pipe. Firstly, they need the building inspector to come first and check it over. Once he's done that, they will bed the pipe completely in the shingle, and also concrete around the rest bend there to give it stabilisation.
We've been joined by Mark Medhurst, the site foreman. So Mark, what are we looking at doing next?
Now we finish inside, next we'll bring the machine in, and then we'll mark out the position for the drain lines, bring the machine in and start excavating out ready for pipelines.
The drainage inside the property's been installed. We've now come outside. Stuart, what's next?
All right, Tony, as you can see, Pat and Sean have dug a 450mm wide trench from out inside the property going alongside the property. What we need to do now is change the direction of the run to go down this side of the house, or the flats. So what we use is a shallow inspection chamber. These can be installed up to 600mm deep. As you can see, because we're going to use a 90-degree bend here, we use a 45 on one end and a 45 on the other. So that would be installed down there, the inlet pipe coming in that side and travelling alongside the property. The reason you have to use an inspection chamber is obviously for cleaning purposes later day once it's all been installed, and to be able to rod it and clear any blockages that may happen in the future.
So we've started at the rest bend, we've laid the pipe, we've got to the rocker pipe, gone under the building out to the shallow inspection chamber where we can get access. We've turned the corner and run the pipes all the way along. So Stuart, what's next?
Well, next, Tony, Pat and Sean will be installing a bottle gully on the outside of the property. The reason we're doing this will take the waste kitchen water from inside the property outside into the drainage run. With the unique features of our bottle gully, it has a square top, so you can lay it flat with the wall of the property. It has a 360-degree rotating base, so you don't need any bends at the side of this, so it will directly go straight into the drainage run there. Put it back down there. Also, the bottle gully is trapped, which creates an airtight seal to stop any foul odours coming back up through the drainage run in and around the property. The reason we haven't got there a inspection chamber like we have at the end of each run there is because the bottle gully is roddable, so you can gain access from there down to the pipe to the T-junction, and obviously we can rod from either end of the run there. So that's why you don't need an inspection chamber there.
So we'll go back to Pat and Sean for the installation. We're at the end of the trench now. We've installed the Y junction and I'm looking down, and even I can see this, Stuart. This inspection chamber is much bigger than the one at the other end. What is the reason for that?
Well, Tony, we're now at the end of the drainage run where this will now connect to the main sewer. 450mm diameter manhole base. The reason that is because it's going up to a higher depth. This one can go to 1200mm, whereas the shallow inspection chamber can only go to 600mm. You raise that up by using these 450mm raising pieces, and obviously put the cover on top. Right, we're just going to install the raising pieces. These are 450mm in diameter, unlike the shallow inspection chamber, which is 250mm. They go on the bases just like that. As I said earlier, these can go to a depth of 120 centimetres, and you can adjust them by cutting around the ribs there, so you can go to any depth you like, up to 1.2. Another feature of the 450mm diameter inspection chamber that has 5 inlets, unlike the shallow inspection chamber that only has 3. This gives the base an ability to take other drainage runs from out the site. And to complete the chamber, what you need is a manhole cover that goes on top of that, and now that is complete.
Well, Stuart, it looks like we're nearly finished here.
Yep, we're nearly done. Pat and Sean, we've laid the pipe on a 100mm bed of 10mm shingle. They've just laid another 100mm bed on top of that. Again, to recap, that's to give it its inherent strength. And what they're going to do now is put the oversight back on top, compact it down, and then the trench will be completed.
My thanks to Stuart from Wavin. I hope you've enjoyed today's tutorial video. I've certainly learnt a lot. For more information on the Osma drainage system and all other groundwork and civil engineering products, please visit us on the Rudridge website, www.rudridge.co.uk.